point performs damped oscillations governed by this law. We need to find the amplitude and velocity at t is equal to 0 and time at which the point reaches the extreme positions. So this is our equation, given equation. So this term represents the amplitude of this damped oscillation and it is time dependent. In a normal undamped oscillation, amplitude is a constant, but in a damped oscillation, amplitude decreases with time. And we need to find velocity as well, so let's differentiate that, and this is the velocity. So first part, amplitude at t is equal to 0. So this is the amplitude. So we'll just put t is equal to 0 and this will be the answer. Velocity at t is equal to 0. So in this term, we'll put t is equal to 0 and the velocity is a naught omega. Now time at which the point reaches the extreme positions. So at extreme positions, velocity will be 0. So whenever x dot is 0, those moments we need to find. So let's put x dot is equal to 0. So this term will be 0. That means tan omega t will be omega by beta. Or omega t is n pi plus tan inverse omega by beta. So the time at which this occurs, so we'll just divide omega upon this side and this will be our answer. Now let's compare that with the normal oscillation. So if this were a normal sine curve and they asked time at which point reaches the extreme, so first extreme is reached at t by 4. Next extreme is reached by t by 4 plus t by 2. Then again plus t by 2 and so on. So in that case, our answer should have been t by 4 plus n times t by 2. But that is not the answer here, because graph is asymmetric from peak. So a normal sine curve is of course symmetrical from its peak, but this is not. So this is t by 2 from 0 to 0. Then again from 0 to 0 is t by 2. But if you see the peak, this distance is not t by 4. And as calculated, that distance is this much. 1 by omega tan inverse omega by beta. This term, however, is same, and that just represents n times t by 2. So after this peak, you have to again go by distance t by 2 to get this peak, then again t by 2 to get next peak. But first peak does not come at t by 4, but it comes at this value and not this value, which is t by 4. So you can see the graph is asymmetric. This is less than t by 4 and this is greater than t by 4. But sum total is of course t by 2. And you can also see that here this term, so this is 1 by omega tan inverse omega by beta. Omega and beta are both positive. So maximum value of tan inverse omega by beta will be pi by 2. And that will be when beta is 0. That is, there is no damping. So in case of no damping, beta is 0, this whole term becomes pi by 2. So this term becomes pi by 2 omega. And pi by 2 omega is t by 4. But if there's damping, this term is of course less than pi by 2. So the time period when the peak occurs, this will be less than t by 4. Alright.